Greetings and welcome, friends. Today we are going to expand our minds by graphing inequalities in two variables. That's right. Previously, you may remember this. Let's actually do a quick flashback. Right up here, look at this. Previously, you guys have been able to graph on a number line. Do you remember that? Like this. And if I asked you to graph, say something like x was less than 2, what did we do? Do you remember? I'm going to shade it to the left. Is it a closed circle or open circle? Open circle, shaded to the left. Oh man, he left the door open. Speaking of left, that was rude. Yeah, could someone close the door, please? Help me out. So, x is less than 2 looked something like that. Now today, instead of graphing on a number line, we're going to graph on a coordinate plane. All right, so we're going to have multi-dimensional inequalities. And this is the following as to what they say, right? You might have an inequality like this or that or this or that. And those are all inequalities with two variables because they have two variables, x's and y's. Isn't that great? This, by the way, was a less than sign. This was less than or equal. Greater than sign, greater than or equal. Now, question. Before, when we would solve inequalities, there was like a weird time when that inequality would flip directions, right? It would flip, over on itself. Do you remember what special scenario would occur when I would flip an inequality? Let's do a flashback for that. For instance, if I had 3x is greater than or equal to 9, I didn't have to flip the inequality here, right? My answers would have been x is greater than or equal to 3. But when did I have to flip it? Do you remember? Yeah, if I multiplied or divided by a negative, then it actually would have flipped the inequality. All right? So multiply or divide by a negative, you have to remember to flip that sign. I'm just trying to piece back, some of our older concepts so we know how to do it. But check this out. Check this out. We're starting super simple right here. Example 1. All they want us to know is this a solution? And if this is a solution, basically what this means is that this value of x and this value of y will make this inequality true. Now, that doesn't mean that both sides are going to be equal. In fact, in this case, they can't be. What's going to happen is we're going to check to see whether or not the left side is less than the right side. So let's plug in those values for x and y. So I'll have 2 times negative 1 plus y is now 9. I'll throw parentheses there just for funsies. Is that less than negative 3? That's the question mark that I'm asking. Question. Right? I'm checking, trying to determine whether or not that is true. So 2 times negative 1 is negative 2 plus 9 less than negative 3. Negative 2 plus 9 is 7. Is 7 less than negative 3? Yeah, 7 is bigger than negative 3. So that's false. That means negative 1 comma 9 is not a solution. Okay? Not bad, right? That's just like doing a check. Let's try this next one. So here's a point, an x comma y, and I want to know, does it make this inequality true? That's what I'm trying to figure out. So let's plug in 2 for x minus 3 times negative 2 for y. Careful with that double negative. I threw parentheses just to be safe. Right, I've just plugged in x and y, right? So 2, negative 3 times negative 2 is positive 6. 2 plus 6 is 8. Is 8 greater than or equal to 8? Yeah, it isn't bigger than itself, but it is greater than, equal to itself. There we go. corrected myself there. And because the equal to part, that's true, that means 2 comma negative 2 is a solution. Man, I love my colors here, guys. Isn't this great? I love writing in these colors. I like it. Oh, that'd be awesome. So that's just the idea of, is something a solution? Is something not a solution? Oop, there we go. Let's take a look at this idea. So what if I wanted to graph these? If they have x's and y's, that means my graph is going to need an x-axis and a y-axis, and I'm actually going to have a 2-dimensional inequality. All right? What you see here is a graph of the inequality y is less than 2x. Okay, this dotted line is the line y equals 2x. But notice what they're describing as the solutions here. I'm going to, check this out. I love this. This is so classy. Look at this. Look at this. I'm going to shade right here like they did, because you might not be able to notice that they shaded that in. Right? They're saying all of the solutions are everything in this shaded region. Okay? So the graph of a linear inequality in 2 variables shows all solutions of the inequality on a coordinate plane instead of just a number line. And all of the solutions lie on one side of the boundary line. So here's the boundary line, like so. And all of these are the solutions. Now they call this a half plane. Now the entire square here represents the coordinate plane. But remember, a coordinate plane goes out infinitely in all directions, right? And so they're saying, imagine if I drew a line, and I shaded half of it, right? That's kind of what I'm describing here. Even though this shading isn't half of this square that you see, you could describe it as being half of the coordinate plane, a half plane. All right, and a half plane represents the solutions. Now, question, if I was talking about y is less than 2x, that means that any of the points on this line are not solutions. Actually, let me even label it this way. All right, points that are not in the shaded region, I think you guys would agree this is not a solution. Not a solution, not a solution, right? Not a solution. Those aren't in the shaded region. Now, because this is strictly less than, that means points on the line are actually not solutions either, which is kind of weird, right? That means these are not solutions. The solutions are everything up to that line, but not including it. So here's a solution, there's a solution, right? All of these points would be solutions. All right, everything up to the line, but not including it. Just like here, everything up to the circle, but not including it, were solutions. In the world of one-dimensional inequalities, open circle was, right, everything up to but not including. In the world of 2 dimensions, I'm going to have a dashed, or sometimes I might say a dotted line, and it means everything up to but not including it are solutions. So how do you graph something like this? Oh, you guys are going to have fun. We're going to color today, and tomorrow it's going to be beautiful. I'm excited. It's going to be great. Okay, so what you do is first you graph the boundary line for the inequality. Use the dashed line if it doesn't have the equal part. Use a solid line if it does. Notice that's very similar to open circle, closed circle. Same logic. Test a point that is not on the boundary line to determine whether or not it is a solution, and then shade whichever half works. I actually don't really like, I'm just going to write meh for step 2 and 3. I'm going to have you kind of logically deduce how to shade. I think that there's far more interesting ways of doing that than just like kind of guess and check. So I'll show you how to do it. Here we go. Here's an example. You guys ready for this? Example 2. You got your colored pencils ready? Do you guys want a straight edge? Do you want like a ruler or something? Yeah. All right. Yeah, you could use the edge here. Here, just a minute. I'm going to give you something that's going to need you to be responsible. Don't. One of color, pass those around, and you straight edge. You can also bring that to your geometry class when you take geometry next year, perhaps. All right. So guys, check this out. Y is less than or equal to 2. I want to graph it. The boundary line you could think of as being y equals 2. And what do I know about that line? Well, that's going to be, I could think about that as y equals 0x plus 2. Yeah, yep. So that means the slope is 0. That means the y-intercept is 2, right? And so that's a vertical line is what I'm talking about here. So here's 2, and its slope is 0. So up 0 over 1, up 0 over 1 is just going to be a horizontal line. But this is less than or equal to, question, is it a solid or a dashed line that I want to draw here based on this? Solid or dashed? It's solid. Why did you decide that it was solid? Solid because it includes the line, right? It includes equal to, right? It wasn't just less than. So when I graph this, here we go. I'm going to use my straight edge. And I'm going to draw the best solid line you've ever seen. Okay? And this goes forever, so I'm going to put some arrows on the edge of it, at the ends of it. And now, the other thing to interpret from this is the shading. Y is less than or equal to 2. All right? What values are less than? Less than would be above or below, do you think? Less than, what points are less than this line? The ones above or the ones below it? Yeah, less than sounds like less than, that's below the line. Okay, so I'm going to shade below the line. So I'm going to grab my colored pencils, and here we go. Look at this. This is so cool. I'm going to shade below the line, and I'm just going to shade. And look at that. Thing of beauty. Thing of beauty. So you can color that in, and that means all of my solutions are everything in the blue. Okay? Everything in the blue. That means that let's give you some examples. Is 0, 0 a solution? Yes, that's right here. 0, 0 is a solution. Okay? Is negative 2, 1 a solution? Here's negative 2, 1. Is this a solution? Yes, negative 2, 1. No, that's a less than sign. Is 5, 2 a solution? How about this point? Here's a question. Moment of truth. Gentlemen, be cool. Be respectful. And because the line included equal to, that means 5, 2 is a solution. How about is 3, negative 5 a solution? Yep, it's in the shaded region. All right, how about is 0, 5 a solution? No, not a solution. Okay, so I just want to point out that there are infinitely many answers that make this true, and notice the ones that are solutions algebraically make sense. When is y less than or equal to 2? Well, when y is 2, when y is 1, when y is 0, when y is negative 5, those are all less than or equal to 2. When y is 5, that is not less than or equal to 2. So if I plugged any of these points in for a check, only the green ones would work. All right. All right, let's do example 3. So, actually, wait. Did I have monitoring progress one that's a... Yeah. I want to do monitoring progress 6. I don't know if that's in sequence with what you got. But I want to do a vertical line, just because these can be tricky, and oftentimes, even calculus students might forget which lines are horizontal or vertical. So let's look at monitoring progress question 6. You should be able to find it somewhere in your packet. Before I start doing diagonal lines, I think this would be a good choice. Let's see, I'm just assembling the problem. Problem loading. Download complete. Okay, so here we go. So based on this, x equals a number as a boundary line. This is going to be a vertical line. All right, you might remember that. Vertical lines. Because it's got the equal part, what does that tell me? It's a solid line. And then we'll figure out shading in a moment. Okay, so let me, actually, I'm going to make this line purple. All right, my apologies. You guys just follow along, then this will be gold. So this is a vertical line, and where is this vertical line? How could I find out where this vertical line is? At -4 on the x-axis, right? And it's a solid vertical line. I'll teach you in geometry someday. So it's a solid line, so I draw a solid line. And now the question is, this sign says less than. Which points are less than this line? I can't really talk about points that are above or below, right, Devin? Because the line is the points above and below itself. But this relationship is talking about x. It's not talking about y. X is this axis, not this axis. So when I say x is less than, I shouldn't ask a question about above or below. I should ask a question about left or right. So let me ask you, which way should I shade? Is less than left or right of this line? Well, let's look at the x-axis. What are the points on this? Here's like a 5. Here's a 1. Here's a 0. Here's a -5. It's going to be to the left. And the reason I'm going to shade to the left, right? Because for the x-axis, the big numbers are to the right and the small negative numbers are to the left. So we're going to want to shade to the left. So let's shade it to the left, to the left. Every solution you own is to the left. Here we go. Ooh, look at that. That's beautiful. You guys, ooh. Okay, so I just wanted to show you at least an example of a vertical line before we did the next example. Let's keep going. Let's keep going, Mr. Wadi. Example 3. Oh, this one's going to be so good. I'm pumped about this, guys. Oh. We get to color, guys. We get to color for the next 2 days. These problems used to be such a pain to teach, but now that I just give you pre-printed coordinate planes, it's el más fácil del mundo. We just get to enjoy the fun of graphing. Okay, here we go. Oh, dear. The first thing I'm going to do is I'm going to rearrange this into slope-intercept form. Yeah, let's write this in y equals, I guess, quote-unquote equals. This is not going to be an equals. It'll be a greater than sign. mx plus b format. Okay? Technically, we could graph using a bunch of different ways, but this is actually going to be the most helpful. How could I solve this for y? How could I get y by itself here? We'll move the x to the other side. So I'll have 2y is... Oh, do I have to flip the sign yet? No. 2y is greater than x plus 2. How do I get y by itself now? Yeah, I'll divide by 2. And everybody gets divided by 2. So I'm going to have those 2's cancel out. I'll get y. Do I have to flip the sign? Yeah. I'm dividing by a positive, so I don't have to flip it. Anytime I multiply or divide by a negative, that's when the sign will flip. Yep. Instead of x over 2, I'm going to write that as 1/2 x plus, and then what's 2 divided by 2? 1. So here's my new inequality. Okay? What is the slope of this line? 1/2. Okay? Or up 1 over 2. If you want to think about it, rise over 1. What's the y-intercept? 1. Okay, I'll even plot that point. And then let's also interpret the shading of this. Okay, so based on this inequality, all right, is it solid or dotted? Well, it doesn't have the equal part, so it's actually going to be dashed because there's no equal part, right? And then this is a relationship comparing y to something. Because it's comparing y, Devin, that's going to be a vertical relationship, right? The y-axis is up here, and the x-axis is over here. So vertically speaking, if I say greater than, which way should I shade, above or below? Above is greater than. So let's graph this. All right, we've got this. So here's my y-intercept at 1. My slope is 1/2, so I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Thing of beauty. All right, and careful, you're going to be super excited. You're going to want to draw a line so fast, but remember, it's not a solid line. It's going to be a dashed line. Ooh, just a dash of line. It's going to be beautiful. Just a little bit of flavor of a line, because the solutions won't include the line this time. Let's see if my dash tool still works. Ready? This is going to be the coolest. Oh, look at that. I can draw the best dashed line. Look at that. I can just... And also, if I didn't want... Yeah, look at that. I can draw... Isn't that great? I love it. Yeah, so I can cheat using my computer to draw a quick little dashed line. So there's the line. That's the boundary line. It does still have arrows on it. It goes forever. And which way am I shading this? Up, right? Above. All right, yeah. Yeah. Orange is my favorite color. So guys, so here are my solutions. This is my graph. Isn't this beautiful? Ooh. Naranjas. All right, let's... All right. So that's what the graph looks like. Let me ask you some questions about solutions. So the shaded area represents solutions of this original problem, okay? Question, is 0, 0 a solution? Here's 0, 0. It is not a solution. It's not in the shaded region. Okay? Someone name for me a point that is a solution. Yep, over 1, up 6, right here. That's a solution. -5, 1, right there. That's a solution. All right, there's infinitely many solutions here because there's infinitely many points that I've shaded. What's another solution? 5, 5, yep, right there. 5, 5. Over 5, up 0. Uh-oh. What do you call the other 5? 0, 5, yeah. So 5, 0 is not a solution. But 0, 5 is. And what that means is that if I plugged in 0 for x and 5 for y, it would work. Now, question, is 2, 2 a solution? Yeah. Two, 2 is not a solution. Yeah, it has to be greater than that, and 2, 2, it won't be greater than. So in this case, because it's a dashed line, and it didn't include the equal part, it won't work. Negative 1, 0? Negative 1, up 1 is over the line. Yeah, that works. So negative 1, 1. Yeah, I could find infinitely many points right less than this that work, but once it gets to 0.5, it would not work anymore. All right, so I just wanted you to see that. Let's see, do you guys have monitoring progress question 7? Let's have you guys try that, and I'll be around to help. Monitoring progress question 7. And then maybe we'll do example 4 together. So, you guys give this a try. Put it in y equals mx plus b form. So, you guys put this in y equals mx plus b form, right? All right, so let's see. So x plus y less than or equal to negative 4. Make sure when you're solving these, you don't accidentally forget that you're doing an inequality here. How did you get that solve for y? Yeah, you can grab a different color. Top shelf, you were right. And on the left, bottom one more, one down. There it is. You found them. So let's move that x. And I've got y is less than or equal to negative x minus 4. Question, what is the slope? Negative 1. What is the y-intercept? B is equal to negative 4. Tell you what, I'll plot these points first. Yep, to get y by itself. This was a positive x, so to cancel it out, right, I needed a negative x to cancel it. To move by my slope, it's negative 1, so down 1, over 1, down 1, over 1. I can also find more points going up 1, backwards 1, up 1, backwards 1, like so. Now let's interpret the inequality part. So looking at just this, is this solid or dotted? Solid or dashed? Why is it solid? Why is it solid? It's solid because it includes the equal, right? Because this part right here tells me it's solid. I like to think of it would have been dashed, and then like this little part was like, I got this, and then filled in all the gaps between the dashes and made it solid. But that's my little story about inequalities that I made up. Also, it's less than. Now this is saying y is less than. So which way should I shade? Left, right, down, below, above, less, diagonal? Less than for y will be shaded below. Yep, that is. Because it was less than. Okay? So, this is going to be a solid line. I'm going to make mine purple. I do have a lot of purple shirts now that I teach at BUHS. My New Jersey colors. Yep. When I got drafted by this team, I was like, you know, I should start getting some team colors here. So I bought some purple shirts and ties. All right, which way am I shading? Below. All right. Devin, we'll talk later. Thank you. That's also fine with me. Thank you. So there we go. So that's what it looks like graphing these, right? Nothing too crazy. Question, is 0, 0 a solution here? No. Could someone name a point that is a solution? You don't have to plot these points, by the way. -1, -5, that's a solution. Yeah, -5, 0 is over here. Yep. Question, is -2, -2 a solution? It's on the line. What do we think? It is a solution because it's a solid line. If it includes the equal part, that means the points on the line count. If it doesn't have the equal part, then that means the points on the line would not count. Yeah, dotted lines is when notice this didn't have an equal part. So that means if it's dashed because there was no equal part, right? Cool, cool. All right, let's look at example 4 together, and we'll call it a video, and then we'll have practice. Yeah, we'll do a little word problem together. Example 4, modeling with mathematics. Okay, let's see. Let's define our variables first of all. My variables are going to be, it says, write and graph an inequality that represents the amount of grapes and apples you can buy. So let's come up with 2 variables. Let's let x equal the amount of grapes. I don't know. What should I measure that in? Like just in like single grapes? Well, their prices are per pound. So let's call these pounds of grapes, LBS. Did you guys know that LB is abbreviation for pound, which is weird? Yeah, you also can use a hashtag, which is a pound sign, maybe. I don't know. And Y is going to equal the amount of apples. What should apples be measured in? Pounds. Pound it. All right. Here's our equation. It says you can spend at most $10 on grapes. Check this out. Spend at most $10 on grapes and apples. So that means my total cost is got to be less than or equal to 10. Right? Because that's the way stores work. When you're like, hey, can I have $100 of apples and grapes? And they're like, sure. And you're like, I have a quarter. They're going to be like, no, you can't actually. Because you can only buy things less than or equal to the amount of the money you have, right? You're all with me on that. And then it tells us also the cost of each. So what could I represent over here? What would this equation look like? What do you guys think? Well, that would be pounds of apples plus pounds of grapes is got to be less than or equal to $10. I've got to somehow convert this to the price that I'm spending. Well, if X is the number of pounds of grapes, and grapes are $2.50 per pound, I could multiply those, and that would tell me how much money I spent on grapes. Plus $1 per pound of apples, so 1Y. All right, you with me there? You with me? So let's solve this. Let's solve for y. Subtract 2.5x from both sides. Do I have to flip the inequality when I subtract? Nope. Only multiplying or dividing by a negative. All right, so I'll have y is less than or equal to negative 2.5 x plus 10. Let's see. Yeah, we're almost done. We're good. So my slope, you could think of as negative 2.5. Does anyone know how to represent that as a fraction? Yeah. That's the same as negative 25 over 10. Or, no. It would have been the same as negative 50 over 20. But if I want to reduce this fraction, what goes into both of those numbers? 5. Okay. And what's my y-intercept? 10. Hey, convenient. Mr. Water gave us a graph here. So here's my y-intercept. Let's move by my slope. I'm going to go down 5 over 2. Down 5 over 2. All right, you guys see that? Down 5 over 2 because of my slope. I also, let's check this out. I also, if I go down 2.5 and over 1, those points will actually be on the same line. So if you did want to move by a decimal slope, it's possible, but sometimes it's weird. But it does work out here. Down 2.5 units and over 1 would also work. Question, let's analyze this inequality. Solid or dotted? Solid, because of the equal part, right? And is it, this says y is less than or equal, so y is vertical, so this is an above or below question. Which points are above or below the line? Let's see, which points are less than the line? Points less than the line are going to be where? Above or below? Below. Right? Because it's less than. All right, let's draw my line. Well, normally students close the door when they come back. All right, solid line. Thank you so much. And I'm shading below. Let's see. Now, notice I'm actually shading only inside this triangle. Why do you think that is? Why do you think that is? Yeah, because I can't buy a negative number of pounds of grapes. That we don't know what antimatter grapes look like, or antimatter apples. So yeah, that's right. We're only interested in values that would be greater than or equal to that. So possible solutions are like this. I could buy 2 and 5. Is a point on this line a solution? What do you guys think? Is 2, 5 a solution? Yes, because of the equal part, right? So that means I could buy 2 pounds of grapes and 5 pounds of apples. Is 4, 0 a solution? Yeah, what does that mean in terms of this problem? 4 pounds of grapes and no apples. What if I only want to buy grapes? Or sorry. Or if I only want to buy apples, my bad. 0, 10 would be 0 pounds of grapes and 10 pounds of apples. Now, these solutions that I've shown you, here's, for instance, I could buy 1 pound of grapes and 7.5 pounds of apples. These solutions on the line represent the situations when you spend all your money. You're like, I want all the grapes and apples I can afford. But you actually don't have to do that. I don't know if you guys knew this about life. You don't have to spend all your money. Yeah. This is a solution as well. What's this point? Yep. Gentlemen, quiet. Gentlemen, once again, please. Thank you. 1, 3 is also a solution. That's a solution which I don't spend all my money. That, right? That works. You also could have picked like this. Yeah. Well, you can have half a pound, right? The store will sell you, right? I could buy a quarter pound of grapes and 9 pounds of apples. That's what that point would be. All right, gentlemen, are you getting this? So yeah, that's okay. Yeah, I can have fractional amounts. Yep. Yep. Now, if the question was like about number of people, then I wouldn't want only a quarter of a person. That'd be weird. But since these are pounds of apples and grapes, we can have decimal portions that count. So all of these are possible combinations of apples and grapes. All right, well, thanks for watching, Internet friends. Have a great day.